One major value emphasized in Scrum is focus. Scrum provides constructs to help maximize focus, such as delivering value in short iterations, using a prioritized backlog, defining sprint goals, and adherence to a definition of done, just to name a few. Extended concepts like swarming and limited work in progress add to the emphasis that doing one thing at a time is more productive than multitasking. The inbuilt emphasis found in Scrum on focus and avoiding multitasking is based on studies and analysis showing that doing one thing at a time is more efficient than doing multiple things at the same time. Jeff and J.J. Sutherland cite two examples in their book entitled Scrum, The Art of Doing Twice the Work in Half the Time. The first addresses multitasking at the individual level. It is a cognitive study by Gerald Pashler referred to as dual task interference. The second addresses multitasking at a team level in a book series by Gerald Weinberg entitled Quality Software Management. From the perspective of multitasking impacts at the individual level, Pashler identifies two major categories of task interference: simple stimulus response and psychological refractory period, known as PRP. Simple stimulus response focuses on the impact on reaction time due to simultaneous task execution, while psychological refractory period looks at interference resulting from the simultaneous execution of two speeded tasks, indicating that there are preparatory limitations as well as a central bottleneck. The PRP effect, first observed in 1931, is demonstrated by measuring the impact of response time due to the execution of two successive tasks. The PRP effect has since been observed for a variety of different tasks, ranging from simple to more complex. From the perspective of preparatory limitations, the PRP effect is demonstrated by measuring the impact on response time due to multitasking. In this case, the response time of two simultaneous tasks is measured where the start time of the second task is delayed as compared to the first. The delay is referred to as stimulus onset asynchrony, or SOA. The response time is measured as the time between the task stimulus, referred to here as S1 and S2, and the response to the stimulus, referred to here as R1 and R2. The results show that as the delay between the start times of the two simultaneous tasks increase, the response time decreases, indicating that the response time improves as the degree of task separation increases. In other words, there is a preparatory limitation that correlates to the degree of focus allowed by delaying the start of the second task. The next component of the PRP effect is referred to as a central bottleneck, indicating that the brain can only conduct certain mental processes one at a time, which I will refer to here as single-threaded. In this case, Task 1 and Task 2 both utilize the same mental devices, A, B, and C, where B is single-threaded. As you can see by the dashed line, Task 2 is delayed after finishing process A, as it waits for Task 1 to complete process B. In other words, central bottlenecks delay simultaneous tasks when mental devices being utilized are single-threaded. In the end, multitasking is something that cannot always be avoided, but its negative impacts on efficiency at the individual level have been studied, and the evidence is undeniable. From the perspective of multitasking impacts at the team level, we will address two common situations encountered by software development teams: supporting multiple projects simultaneously and spreading work for a single project across team members such that multiple facets of development are occurring in parallel. Sutherland references a study documented in a book series by Gerald Weinberg entitled Quality Software Management, where he describes the efficiency impact of multitasking across multiple projects on software teams. Basically, as the number of simultaneous projects increase, The loss of efficiency due to context switching increases dramatically, which reduces the percentage of the time the team actually spends working on all the projects as a whole. Sutherland points out the essence of lean manufacturing, which is to eliminate as much waste as possible. One significant area where waste can occur is in excess inventory buildup, since partial work has been completed representing an investment, but nothing of value has actually been delivered. This concept can be extended to software development teams, in that work started represents inventory until it is completed, which only then represents delivery of value. As a Scrum team works through a sprint, they may be tempted to start a large portion of the items in their backlog early, essentially dividing the items across team members. This situation usually results in a lot of items started, but very few being completed. If the team enforces a concept called Work in Progress Limits, or WIP Limits, they reduce the number of items allowed to be in progress at any given time. This forces the team to focus on finishing items, thus delivering more value, and thus increasing the likelihood of completing all of the work that they committed to during the sprint time box. In summary, we can conclude that multitasking can have a dramatic impact on efficiency at both the individual and the team levels. 3 ways organizations can help Scrum teams reduce multitasking and become more efficient are to allow the Scrum Master to protect the team from external demands, which reduces multitasking at the individual level, discourage assigning multiple projects to individual Scrum teams, and emphasizing policy that encourages teams to establish work in progress limits.